Jai Jayendra, Namaste and welcome to my channel. Today we are going to solve the 79th question of the problem solving series and the fourth question of the topic linked list. The difficulty level for this question is easy and this question has been asked in Google, Meta, Microsoft, Amazon, Apple, Adobe, Oracle, Uber and many other companies. Okay. Intersection of two linked lists. So we are given the head of two linked lists and this linked list A and B intersect at a point. We need to return that pointer, that list node. Okay, so here in this example you can see 41845. This is the first linked list and this is the second linked list 961845. Okay, both this linked list intersect at 8. 8 is the common point, intersection point, so we need to return this 8. Okay, 845. So the 8 pointer at 8 we need to return. Okay, here 19124 324. So 19124 is A and B is 324. Both of them intersect at 2. So we need to return the pointer at 2. Okay. So how do we solve this? This looks very simple, right? What can you do? If the size of the lists were same, say if the A was 134 and B was 434, then at that time we could have traversed both the list and we can see if the list, if it is A and it is B, then if A pointer A is equal to pointer B, because the memory they have taken is same, right? The memory is same. We are not dealing with the number, the pointer memory, right? So that is same. So if the name could be different, but the memory is same. So if A and B are pointing to the same memory, then they are same. But A and B are not pointing to the same memory. This is 1 and 4 and they are different. And when we go to A to the next, A goes to A next and B goes to B next, then this is same, 3, right? Because the memory is same, okay? So the memory node, that list node is same. So when the size is same, then we can see that both can traverse together, and whenever the memory is same, the list node is same, we get it. Okay, but if the sizes are different, then what do we do? So you know that when they intersect, after intersecting point they are same, the size is same here. Okay, so if you consider the size of A as m plus n, and the size of, if the size of this is n and the total size and size of this is m, okay, and the size of this is p, so B size is say p plus n and A size is m plus n. Okay, now this is same, but the difference in the size is either p minus m or m minus p, whichever is bigger. So if we remove that difference, okay, so say this one 41, so here in this example 19124, right, and this is 3. So if we see the count of the size of A is 5 and size of B is 3, right, but this size is same, right, the common size is 2. So if we subtract the size of A minus B, since A is greater, that is 2, right? So if we traverse this 2 before only, and then we start traversing A and B together, we'll get a point where A and B will be same, right? And that would be our intersecting point, as simple as that. So let's do it. First we will find the size of A. Okay, so let's take, we need to store extra value, right? This node A is equal to A and strict B is equal to B. Okay, so int m is equal to 0, n is equal to 0, while a not equal to null. Okay, we increase the size. A is equal to a next. Okay, and we do a m plus plus. Okay, same we do for PB. while VB not equal to null, we do a VB is equal to BB ka next and n plus plus. We get the size of both A and B. Okay. Now, if m is greater than n, then what do we do? While if m is greater than n, that means size of A is greater than size of B, right? So while m, if m is greater than, so we need to traverse how much it is greater, right? So what we'll do, we will make while I will take int I equal to 0, right? And we will, while I not equal to m minus n, okay? That till that time we will make A is equal to A is next, because we have A already, right? A has already reached null, and I plus plus, okay? So when I will become m minus equal to m minus n, till that time we have reached the extra part of A that is present, right? And then we can go together. Same we will do if n is greater than m, then while I, okay, now I equal to 0, the same thing, right? It would go in one of them, not in any other than else if it would be else if. So while I not equal to n minus m, B is equal to B is next. I think you are understanding it, right? I plus plus. Okay. So both these conditions, we have removed the extra elements that are present in either A list node or B list node. Okay. Now we have got this. Now what we'll do, while A not equal to B, okay, what we'll do, A is equal to A next and B equal to B next, right? There will be time when this A and B will be equal, and that time only we will return either A or B, whatever you return, that is the intersecting point. Okay, I hope the experience is clear. This is a very simple question. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. The time complexity is order of n and the space complexity is order of 1, right? We have not taken any extra space. This is the name is there, we have not created any extra node. Okay, so try it yourself. The link is there, and then come to my code walkthrough section. Here is the code walkthrough of the 79th question in the LeetCode platform, intersection of two linked lists. Let's look at this question has been asked in these companies. You can see the name of the companies. Okay, Google, Amazon, TikTok, Uber, Nvidia as well. Okay, and the example is similar. So you can see this 8 is the intersection point here, 2 is the intersection point here. There is no intersection point. If there is no intersection point, then I think we should return null, right? Okay, so let's look at the code. Let's do the code walkthrough. So we have this get intersection node function. We have this head A and head B as the head of the two linked lists, and we need to find the intersection point. So we take the extra dummy this list node so that we can traverse them, head A size, head B size, and then we traverse them and find the size of the linked list. Head size, A size is the size of the linked list head A, B size is the size of the linked list head B. After doing this, we see if A size is greater than B size, we traverse this linked list head A is till head next, so that we traverse the extra space, which is extra number of elements that are present in A. If there are extra elements present in B, we do the same for this. Okay, and then while head A is not equal to head B, we traverse both of them. Whenever they are equal, we can return head A or head B, anything. For example, we can return here head B, it is same. And here what we have done here, int I equal to 0, j is equal to 0. In the code that we have shown, I just done I equal to 0 because we don't need j, because either we are going here or here. Okay, so
just we can change it I and I plus plus. Okay, let's submit this directly. So you can see this has been accepted. Okay, see you all soon in the next video, where I'll be explaining the 88th question of the problem solving series and the 5th question of the topic linked list. Jai Jinendra.